Hello student. So let me start our the new subject, that is the organic chemistry 1. The code of the subject is MGC 102. So in previous lecture we have discussed about some basic chemistry topics like electrophile, nucleophile, electronegativity, ionization energy, and so on. But today we are start with the chapter 1. Right? Chapter 1 is the reaction pathway and effect of structure on reactivity. That means how we can draw the reaction, how we can draw the mechanism, what is the effect of catalyst, what is the effect of reagent on the particular reaction. We will discuss in these topics. Now the first topic in this chapter is the homolytic and heterolytic bond fission. Homolytic and heterolytic bond fission. So there is a one phenomena to breaking of any bond. Now as you know that to break any bond, for example I want to break this bond, so for bond breaking phenomena is always endothermic in nature. Endothermic means you have to supply some amount of energy. Bond breaking phenomena is always endothermic in nature, while suppose there is a formation of carbon-carbon bond, so bond formation phenomena is always exothermic in nature. So हम ये बोल सकते हैं कि जब कोई न्यू बॉन्ड फॉर्मेशन होता है तब वो एनर्जी रिलीज करती है. So we can say that here delta H is equal to negative, and here suppose कि आपको ये bond break करवाना है, at that time we have to supply some amount of energy. That means for this case delta H is equal to पॉजिटिव. सपोज के थर्मोडाइनमिक के टर्म में हम बात करते हैं तो उसके लिए डेल्टा एच पॉजिटिव रहेगा. इन केस ऑफ द एंडोथर्मिक रिएक्शन मीन्स वी हैव टू सप्लाई अमाउंट एनर्जी, दैट मीन्स पॉजिटिव हम सप्लाई कर रहे हैं एनर्जी को. यहाँ पे क्या हो रहा है, एनर्जी रिलीज हो रही है. सो व्हेन न्यू बॉन्ड फॉर्मेशन अकर, एक्सोथर्मिक रिएक्शन, बॉन्ड ब्रेकिंग, एंडोथर्मिक रिएक्शन. राइट नाउ होमोलाइटिक एंड हेटेरोलाइटिक बॉन्ड फिशन. Let me start first with the homolytic bond fission. Homolytic bond fission. Okay. So in this case, suppose there is a one bond X and Y. So here X and Y is bonded with the covalent bond. Now what is meant by covalent bond? So in case of the covalent bond, one electron from X and one electron from Y. So we can say that here sharing of electron. So if two atoms share electron and form the new bond, then we can say that it's a covalent bond. Suppose by any means, by supplying heat or by providing the UV radiation, photon, by any means, if you break this bond in such a way that X gets one electron, Y gets one electron. So here X free radical plus Y free radical is generated. So we can say that in case of homolytic bond fission, always free radical is generated. Is it okay? In case of the homolytic bond fission, always free radical generated. Now one more thing, this free radical is highly reactive in nature. This free radical is highly reactive in nature. That means, suppose let me take one example. For example, hydrogen molecule. This is hydrogen molecule इसको हम H2 ऐसा भी बोल सकते हैं. So when hydrogen molecule is break the bond by homolytic bond fission, at that time H radical plus H radical is generated. Now as you know that the H radical is not stable. Suppose if we give this H radical to Cl radical, so it gives HCl. That's why we can call it that the free radical are always highly reactive in nature. Is it okay? Now one more characteristic of free radical. Free radical can combine with electrophile and nucleophile. Free radical can combine with the electrophile as well as nucleophile. For example, here hydrogen is radically charged. Suppose Cl minus attack with it, so it form bond. Suppose one bromine plus is also there, so it also form bond. So free radical is highly reactive in nature, that's why it react with the electrophile as well as nucleophile. Is it okay? So in case of the homolytic bond fission, there is a breaking of bond in such a way that each of the participant atom or group of atom. For example, we can say that hydrogen is atom, H2 is the group of atom, OH is the group of atom. Is it okay? Cl is the atom. So breaking of bond in such a way that each of the participating atom gets one electron and the product is always free radical, right? So we can say that here the breaking of bond in symmetrical manner. So this bond can be break by light, UV light, photon, heat, or by peroxide. Many a times we will discuss in the later classes that for formation of free radical we require some oxidizing agent in the sense of peroxide, hydrogen peroxide, metachloroperbenzoic acid, peracetic acid. We will discuss this per acid in the later class, but here sometimes peroxide is used to generate the free radicals. Is it okay? Okay. Now let me start with the new topics. Heterolytic bond fission. The second one is the heterolytic bond fission. So on the basis of its name, we can conclude that there is one type of hetero, not homo. Homo means same, hetero means different. So there is a heterolytic bond fission. Let me take the same example. Suppose there is a X and Y bond. Now as we know that any bond is formed by the two electrons. Now breaking of this bond in such a way that out of these two atoms, one atom gets both the bonding pair of electron. So we can say that here Y is negatively charged. Why? Because it takes up both the bonding pair electron toward itself, right? And the second species is X plus. So here always ions is generated. In case of the homolytic bond fission, always ions are generated. Okay, now for example we take HCl. So as we know that in case of the HCl, chlorine is more electronegative. Its electronegativity approx 3. So here chlorine is more electronegative, that's why it attracts the bonding pair of electron toward itself. So we get chlorine minus and hydrogen plus. So this is also ions. Okay. So in case of the heterolytic bond fission, always positive and negative ions are generated. Is it okay? So there is a difference in homolytic bond fission and heterolytic bond fission. Homolytic and heterolytic bond fission is depend on the reaction condition. If you supply the peroxide, homolytic bond fission occur. If you supply simply heat, yeah, it's also depend on the substituents, or we can say that atom or group of atom. Clear? Now the second topic in this chapter is the electrophile and nucleophile. We already discussed it in last lecture, but let me see some more information about it. Electrophile and nucleophile. Let me first discuss the electrophile. So electrophile is designated as E प्लस, हम इसको E प्लस के हिसाब से जानते हैं. चलो, इलेक्ट्रो, लेट वी expand this one as electron. File means that we supposed to think as fillings. So fillings towards the electron is known as electrophile. Fillings towards the electron is electrophile. For example, suppose there is a nucleus of atom. Here is the electron. So we can call that this atom is electron rich. So electrophile can attack here because here positively charged. So we can say that electrophile is always electron deficient. Electrophile is always electron deficient in nature. How? Because it contains the positively charged. For example, H plus, Br plus, NO2 plus, right? LCl3, Lewis acid. This is known as Lewis acid because it contains the empty p orbital. Bf3. So all these are act as a electrophile, or we can say that the positively charged species generally act as a electrophile. And Lewis acid, इसका हम यूज़ करेंगे आई थिंक हमने करा भी होगा, फिडरक्राफ्ट अल्काइलेशन, फिडरक्राफ्ट एसाइलेशन, इसमें एनहाइड्रस LCl3 हम यूज़ करते हैं. BF3 हाइड्रोबोरेशन रिएक्शन में यूज़ होता है. So these all are the electrophile. They have tendency to attack at the site where more electron densities exist. Let me take one organic example. For example, CH3, toluene. So as we know that the methyl group is electron donating in nature. Methyl group is electron donating. So we can say that here ortho position and the para position is electron rich. Due to the electron donating influence of the methyl group, ortho position and para position is electron rich. That's why any electrophile, for example Br plus, either attack on ortho position or attack on the para position. Is it okay? Why? Because if we draw the resonance structure of this molecule, then here ortho position and para position occupy the negatively charged. So we can say that the ortho position and para position is electron rich. That's why electrophile attack on ortho as well as para position. Is it okay? So electrophile, जब वर्ड आपके माइंड में आता है, यू हैव टू सपोज टू थिंक अबाउट द E प्लस. द प्लस डेजिग्नेट द इलेक्ट्रॉन डेफिशिएंसी. Electrophile, electron fillings, positively charged, generally act as an electrophile. Their attack on electron rich site. Is it okay? So we can say that the electrophile can be positively charged or neutral. Okay, let me start with the new one, nucleophile. Second term is nucleophile. Okay, so nucleophile हम इसको ऐसे लिखा दें, NU माइनस. चलो इसका भी हम वर्ड का थोड़ा डिफ्रेंशिएशन करते हैं. सो न्यूक्लियो मीन्स न्यूक्लियस and files means fillings. Now as you know that the atom and nucleus of any atom contain the proton, and we know that the proton is electron deficient. Generally we designate it as a positively charged P plus, right? So here proton is electron deficient. So generally nucleophile can attack on the nucleus. Now as we know that the nucleus is electron deficient, right? Nucleus is electron deficient. So nucleophile can attack on the positively charged site. Nucleophile can attack on positively charged site. Is it okay? Let me take one example. Now yes, nucleophile is two types. It may be negatively charged or it may be neutral. Means nucleophile either contain negative charge, for example Cl minus, Br minus, Cn minus, OH minus, right? So this is the negatively charged containing nucleophile. There may be neutral also, for example water. As we know that due to the two lone pair on the oxygen atom, it acts as a nucleophile. Let me take one more example, ammonia. So here nitrogen containing lone pair, so this lone pair can be donated to any other species. Okay, let me discuss one more topic. As we know that in case of the H2O there is a two lone pair, but we know that oxygen has maximum valency is 3. For example, ऐसा हमने पहले कभी देखा होगा H3O प्लस, जिसको हम बोलते हैं हाइड्रोनियम आयन. सो मैक्सिमम वैलेंसी ऑफ ऑक्सीजन इज 3. सो सपोज इन केस ऑफ द वाटर 2 हाइड्रोजन and 2 lone pair, so we can say that 2 lone pair are there. So 4 valency possible होनी चाहिए ऑक्सीजन में, but out of this 2 lone pair, one is called as delocalized lone pair and the one is called localized. Localized means a lock है, localized means a lock है, एक किसी को भी a lone pair अपने देगा नहीं, लेकिन ये क्या है, delocalized, it can donate to any other electrophile. ठीक है, कोई भी एटम ले लो, सपोज के क्लोरीन है सपोज, तो इसके पास 3 लोन पेयर होगी, राइट. सो 3 लोन पेयर में से 2 है वो लोकलाइज होगी, 1 है वो डीलोकलाइज होगी. मीन्स ए 1 को वो डोनेट कर सकता है लेकिन ए किसी को भी डोनेट नहीं करेगा. दैट्स व्हाई वी कैन कॉल दिस Cl माइनस, इट इज ए न्यूक्लियोफाइल. यहाँ तक ठीक है. सो इलेक्ट्रोफाइल एंड न्यूक्लियोफाइल मोस्ट इम्पोर्टेंट in any organic reaction. So you have such a mastery that you can identify the which reagent is act as a electrophile, which one act as a nucleophile. For example NaOH. So in case of the NaOH, we can call that here OH minus. So we can say that it is act as a nucleophile. It is act as a nucleophile. Now one more and important thing is that nucleophile and base, this is two reagent is same but the function is two type. It act as a base as well as nucleophile. For example, suppose any of the reaction I am adding OH minus, for example here let me take one acetone. Suppose we add the OH minus. Now OH minus can do two things. First one, OH minus act as a base. So what is the role of base? So base always abstract the proton. So here also proton, here also proton. So we can say that when OH minus act as a base, then we go to the CH2 minus. Then we go to the CH2 minus. Right. Okay. So when OH minus act as a base, it gives abstract the proton and it gives CH2 minus. Suppose it act as a nucleophile. Suppose OH minus act as a nucleophile. At that time OH minus here, it can attack over here, because as we know that out of the carbon and oxygen possesses partially negatively charged and carbon possesses partially positively charged. So OH minus can easily attack on this electron deficient carbon. So the product is CH2, here OH attack, this CH3 as it is, and here conversion of OH minus, sorry O minus. Is it okay? So any nucleophile can also act as a base. It can abstract the proton or it can attack as a reagent on the reactant molecule. So there is a two function. It may be act as a base or nucleophile. Is it okay? So depending on which type of reaction you required, you need to add this one as a base or nucleophile. Suppose you want to abstract the proton, then you have to take as a base. Suppose you want to add OH minus, then you have to take as a nucleophile. Clear? Okay, now the next topic is types of chemical reaction. Types of chemical reaction. Now first one is the what is the reaction? What is the reaction? What is the reaction? So in case of the reaction, reactant is converted to product. So we can say that the organic compound can be transformed from a reactant to product is known as organic reaction. So transformation of reactant to product is the organic reaction. Now there is a mainly there are 7 types of chemical reactions. There are 7 types of chemical reaction. Let me discuss one by one of each. So the first one is the addition reaction. I think you are already know one about this, or addition reaction. Now in case of the addition reaction, your starting material is always unsaturated compound. Your starting material is always unsaturated compound, and the product is always saturated compound. So we can say that there is an addition of something. There is an addition of something in pi-orbital system, and it gives saturated compound. Or we can say that there is an addition in unsaturated compound which is converted to saturated compound. Now the important characteristic of addition reaction is that there is an addition of all the reactant reagent, and it gives always a single product. यहाँ पे जो कुछ भी होगा वो सब मिल के एक सिंगल प्रोडक्ट फॉर्म करेगा. फॉर एग्जाम्पल सपोज इसको हम ले लेते हैं. यहाँ पे कुछ भी हो, सपोज कि हम आर 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 कर देते हैं. यहाँ पे आर इज इक्वल टू एनी अल्काइल ग्रुप, एनी एराइल ग्रुप हो सकता है. सपोज रिएक्शन ऑफ दिस विद दी H2. सो देयर इज अ ब्रेकिंग ऑफ वन बॉन्ड. Here is the partially suppose negative charge, here partially is positive charge. Now breaking of H2, so one hydrogen attack on this carbon, second hydrogen attack on this carbon. So carbon single bond is there. 4 are as it is. One hydrogen attached to this carbon, and the second hydrogen attached to this carbon. So here double bond is there, so we can say that it's an unsaturated system. Here all are the single bond, so we can say that it is saturated system. Is it okay? So here unsaturated compound is converted to saturated compound. Unsaturated compound is converted to saturated compound. Let me take one more example. Suppose the same reagent attack on the Br2. So here carbon, one bromine this side and the second bromine this side. चलो यहाँ तक तो कोई इश्यू नहीं था, क्योंकि यहाँ पे भी आर था, यहाँ पे भी आर था. लेकिन सपोज हमारे पास कुछ ऐसा रिएजेंट है जहाँ पे एक कार्बन है. सपोज यहाँ पे H है, CH3 है, ये CH3 है, ये भी CH3 है. नाउ वी कैन कॉल दैट दिस इज asymmetric alkene. This is known as asymmetric alkene. Asymmetric alkene. Why asymmetric alkene? सपोज कि यहाँ से हम कोई प्लेन पास करते हैं, तो यहाँ तक ये साइड है वो हाइड्रोजन मिथाइल है, ये साइड वो है मिथाइल है. In this case, addition reaction is carried out as per the Markovnikov rule. I think आप जानते होंगे मार्कोनिकोव रूल. अगर नहीं जानते हैं तो आपको ये जानना चाहिए. मार्कोनिकोव रूल क्या है? सपोज कि हमें इसमें HCl का एडिशन करवाना है. तो एडिशन रिएक्शन, योर स्टार्टिंग मटेरियल अनसैचुरेटेड कंपाउंड, final product is saturated compound, you have to add the HCl. Now in case of the HCl, hydrogen is positively charged, chlorine is negatively charged. Now as per the Markovnikov rule, more electronegative element more electronegative element always attack on the site which have lower number of hydrogen. सपोज कि ए कार्बन के पास 1 हाइड्रोजन है, ए कार्बन के पास हाइड्रोजन है नहीं है, सो दिस नेगेटिवली चार्ज अटैक ऑन दी लेस नंबर ऑफ हाइड्रोजन कंटेनिंग कार्बन. मोर इलेक्ट्रोनेगेटिव, लेस नंबर ऑफ हाइड्रोजन. ए इलेक्ट्रोनेगेटिव का आपको अटैक उस साइड पे करवाना है कि जहाँ कार्बन है उसके पास लेस हाइड्रोजन होंगे. सपोज कि यहाँ पे हमने मिथाइल की जगह हाइड्रोजन ले लिया है, तो इस बार Cl का एडिशन यहाँ पे होगा. आपको मोर इलेक्ट्रोनेगेटिव का एडिशन वहाँ पे करवाना है कि जहाँ नंबर ऑफ हाइड्रोजन लेस है. यहाँ पे 1 हाइड्रोजन है, यहाँ पे इस कार्बन के पास हाइड्रोजन नहीं है, दैट्स वाई दिस नेगेटिवली चार्ज एटम, और वी कैन से दैट इलेक्ट्रोनेगेटिव एलिमेंट अटैक ऑन दिस कार्बन. सो द प्रोडक्ट इज CC. Here Cl, here H, remaining as it is HCl3. यहाँ पे भी CH3, यहाँ पे भी CH3. Is it okay? So this is the addition reaction. चलो, I think यहाँ तक कोई प्रॉब्लम नहीं होगा. चलो, नेक्स्ट रिएक्शन हमारे पास है सब्स्टिट्यूशन रिएक्शन. सब्स्टिट्यूशन रिएक्शन हम डिस्कस करें उससे पहले हमें डिस्कस करना है एलिमिनेशन रिएक्शन. Okay, in case of elimination reaction it is totally reverse of addition reaction. For example, here saturated compound is converted to unsaturated compound. Here saturated compound is converted to unsaturated compound. एडिशन रिएक्शन में क्या था, unsaturated compound converted to saturated compound. Here saturated compound converted to unsaturated compound. Let me take one example. For example, CH3 CH Br CH3. आपको क्या करवाना है, एलिमिनेशन करवाना है. वी हैव टू एलिमिनेट रिएजेंट. चलो, एक मैं इम्पोर्टेंट कैरेक्टरिस्टिक बोल देता हूँ ऑर्गेनिक रिएक्शन की, कि कोई भी ऑर्गेनिक रिएक्शन अगर कोई सिंपल मोलेक्यूल लाइक H2O, CO2, CO, HCl, मिथेनॉल, सपोज कि ड्यूरिंग रिएक्शन अगर कोई ऐसे सिंपल मोलेक्यूल रिलीज हो सकते हैं, तो वो रिएक्शन ऑलवेज इसको रिमूव करने की टेंडेंसी रखेंगे. If any organic reaction is proceed in such a way that this type of simple molecule can be released, then always do it. कोई भी रिएक्शन ऐसे सिंपल मोलेक्यूल रिलीज करवाने की टेंडेंसी रखेंगी. यहाँ पे क्या है, इस कार्बन के पास Br है, यहाँ पे सपोज कि हम इसको हाइड्रोजन को यहाँ पे रख रहे हैं, तो रिमूवल ऑफ हाइड्रोजन फ्रॉम हियर, ब्रोमीन फ्रॉम हियर. अगर इसको हम बोलते हैं तो इसको याद हो तो हम विसिनल बोलते हैं. पास के कार्बन में से 2 एटम और ग्रुप ऑफ एटम को रिलीज करते हैं. पास के कार्बन है तो इसको हम विसिनल बोलते हैं, राइट. विसिनल एंड जेमिनल, 2 कंसेप्ट इज देयर, विसिनल एंड जेमिनल. विसिनल में क्या रहता है कि 2 जो फंक्शनल ग्रुप है वो पास के कार्बन पे रहते हैं. जेमिनल में क्या रहता है कि 2 फंक्शनल ग्रुप है वो सेम कार्बन, वो हम बोल सके पास पे घर में रहते हैं, ये एक ही घर में 2 रहते हैं. सो हियर compound is saturated. So here removal of hydrogen from here, bromine from here. So ए कार्बन की एक वैलेंसी फ्री हुई, यहाँ पे Br माइनस निकलेगा, यहाँ से Br प्लस निकलेगा. अगर हम इसको यहाँ से Br माइनस के हिसाब से निकालते हो तो कार्बन पॉजिटिव रहेगा, यहाँ पे हाइड्रोजन को प्लस के हिसाब से निकालते तो यहाँ पे नेगेटिव रहेगा. ये नेगेटिव और पॉजिटिव कंबाइन होकर यहाँ पे क्या बनाएंगे, डबल बॉन्ड. सो ये CH3 CH डबल बॉन्ड CH2 and the removal of HBr, hydrobromic acid or hydrogen bromide. Is it okay? So in case of the elimination reaction, saturated compound is converted to unsaturated compound with the liberation of some simple molecule. Clear? Now suppose let me take one example. सपोज ए रिएक्टेंट है आपके पास. चलो, तो अब क्या रहेगा कि यहाँ से भी वो हाइड्रोजन निकाल सकता है, यहाँ से भी हाइड्रोजन निकाल, चलो ब्रोमीन को तो निकलना है क्योंकि वो बेस्ट लिविंग ग्रुप है। ऑल हेलोजन आर एक्ट एज ए बेस्ट लिविंग ग्रुप, ऑल हेलोजेंस आर एक्ट एज ए बेस्ट लिविंग ग्रुप। फ्लोरीन को हम कंसिडर नहीं करते इसमें, फ्लोरीन है वो लिविंग ग्रुप नहीं रहेगा, एक्सेप्ट वी कैन से दैट एक्सेप्ट फ्लोरीन, एक्सेप्ट फ्लोरीन। So there are two ways, removal of bromine from here, hydrogen from here. So one product is like that, CH3 CH double bond CH CH3. Suppose if we remove this hydrogen, in this case CH3 CH2 CH double bond CH2. So we can say that this is more substituted alkene, this one is the more substituted alkene, and this one is the less substituted. How it is less substituted? Because here कार्बन के साथ मिथाइल है, हाइड्रोजन को सपोज कंसिडर नहीं करते हैं, तो यहाँ पे एक मिथाइल है, यहाँ पे एक मिथाइल, लेकिन इसके पास क्या है, एक सब्स्टिट्यूशन है, लेकिन यहाँ पे तो हाइड्रोजन है, हम R को एज ए सब्स्टिट्यूशन कंसिडर करते हैं, यहाँ पे 2R है। अल्किन के जो कार्बन डबल बॉन्ड है उसके पास 2R है, यहाँ के अल्किन जो कार्बन डबल बॉन्ड इसके पास ओनली 1R है। सो जनरली दिस वन इज फॉर्म एज ए मेजर प्रोडक्ट, ये हमारा मेजर प्रोडक्ट रहेगा, ये रहेगा माइनर प्रोडक्ट। ठीक है, चलो तो यहाँ तक हम रखते हैं, नेक्स्ट लेक्चर में हम स्टार्ट करेंगे सब्स्टिट्यूशन रिएक्शन। थैंक यू ऑल, हैप्पी लर्निंग।